Welcome to another CO2 Monday in the Refrigeration Mentor podcast. I had questions on like purity of refrigerant. We're going to get into a little bit about that and the differences and what you need to know and what don't you need to know and what I think compared to other people out there. And we're going to dive into some of the main manuals that I really believe will help you learn CO2. Doesn't matter where you're at in the world, maybe the units can't really tell, but these are some of the easiest ones to access when you go and search on Google, because there is a lot of information out there for CO2. Google is amazing now, but you can get down into rabbit holes really quickly in refrigeration. I've seen it many times. And I'm going to show you some of the manuals that I use, some of the manufacturers that I really learned from and from their teams. So a lot of the people that I use and I suggest that I work with their teams and they teach me and they educate me and they get me better. But I think it's very important for all of you to invest that time as well. And we're going to dive in a little bit too on some P&IDs out of some of the manuals. One of the biggest things that I really believe on any system, if you want to be so good at like a system you're working on, you need to understand engineering behind it. And this is why I see technicians that go into manufacturing positions, roles, they're some of the top people at those organizations, because as a technician, you understand how to work on the equipment. We don't always understand how it's built. We can fix the problem at hand, but when we learn how it's engineered and designed, you're really unstoppable. So I'm going to dive into a few different things that hopefully, and I know this will help. This will help. The time you invest in yourself and your knowledge is going to help you grow. I'm just going to share the screen for those of you that are watching. And for those of you who are listening, the three manuals I'm going to talk about today is Hillphoenix Advancer one. And then there's manuals for Advancer from Hillphoenix, and then also Advancer in Denmark. So you need to go to their website, get into their portal, and then you can get all their free trainings and their download. Why I really like the Hillphoenix Advancer manuals, because they put a lot of information there for the technicians. They explain how their controls work or how a process works in their system. And this is what I like about them. They don't mind sharing this information because they want the systems to work great. And they know that the technicians need to know that at 2 o'clock in the morning, 3 o'clock in the morning, when there's an issue. They don't really understand how the system works. The other one is Vapco Systems LMP. These guys are really big here in Canada, starting to grow in the US. And this is actually their newest manual. So I consistently go each month and look if the manuals have been updated, see if they added some new information, some new content. And I dive into them to really look for any new information that I can help share with other technicians who are working on this equipment. Because I know I'm talking to more and more technicians who have not worked on CO2, but they're in the position where they have to learn it right away without going to any training. And this is what concerns me. I want people to feel safe and feel confident when they're out there working on this refrigeration system. Because at the end of the day, it is still refrigeration, but we need to understand the safety. And the last one is the Kaiser Warren manual. I always like this manual because there's so many pictures on there. And I've sat in on many trainings from the team to continue to share the knowledge and teach me and educate me. So where I want to start with is actually, well, let's start with the Vapco one, LMP one. Why you need to consistently read the manuals. I've read each of these manuals dozens of times. So this one that I was going through, they have done some updates since Vapco purchased System LMP in the manual that I've noticed. And as you can see, the first step is getting into the table of contents of any of these manuals. So doing research is very important. And it took me many years to figure this out. And I talked about this many, many times before. So if you're listening on there, you need to get the manual. So those of you who are on the podcast, go into the description notes if you're not driving and then look at the manuals. But you want to look at the table of contents, because if you understand the basics of it, that usually is the first few sections of a manufacturer's manual. Understanding the critical point, the triple point, the dry ice, the diagrams, pressure, temperature. So most manuals, that's what you'll see at the beginning, because they want to kind of give you an introduction of what CO2 is all about. But when you get in there, you dive down into the specific components of the system and installation requirements. That's usually where I will jump to. Like I would jump to right here, page 21, right off the bat, and start from there. It's easier for me to because they got a lot of great information. As you can see here, I highly recommend you got to read this stuff first, right? It goes through all the basics. But where I want to start today is where right here. This is really interesting to me. So as you can see here, grades of refrigerant. This is something that's been going on. I've been hearing about this for years. What grades you should be using, what purity of refrigerant. When I talk to people in Europe, it's different in North America, different in Canada than in the US, different in the US. In the US, like depending on who you talk to, is depending on the kind of refrigerant that can be installed in the system. And I've done a lot of research on this, probably 20 plus hours lately, maybe even more than 20 plus hours on trying to get an understanding of this. Because when I go search purity of CO2 online, there's just so many different things from Lindy and Air Liquid and Messer, I believe they're called. So many different, and then everything's close. You'll hear 99.9%, 99.9%. And then when you look inside those, I've even seen many where bone dry here said it's 99.8%. Then I heard that bone dry is 99.9%. There's so many, and it's like at 20% moisture or less than 20 parts per million moisture, sorry, less than 10 parts per million moisture, less than 5 parts per million moisture. At the end of the day, if you're a technician out there and you've recovered gas from a system, when you put the gas back in, you usually put it through filter dryer. So when you start to get lower purity of refrigerants, you use a filter dryer. I've seen many manufacturers, you'll go look in different manuals, kind of like I believe the Kaiser Warren manual is going to say they recommend not using anything less than Coleman grade. That's fair. I'll see in the Bitzer manual, it'll say it's called N4.5. So I want to give you a kind of a look at what all these numbers here. So this industrial grade, when I talk with people in Europe, they're like, that's an N2.5 grade. So this is really what it means, how to read purity levels. And this took me a long time to figure out. Do you think it'd be pretty simple to look it up? So 99, so you put a 2 for that, 0.5. So it'd be a grade N2.5. So for a bone dry, this would be a 2.8, N2.8. I'm not sure just yet what the N means. So if any of you on the call here knows what the N is, please share that with me. But N, this would be N2.8. Okay, this bone dry, that's what Vapco LMP recommends. That's what Arneg Systems recommends. A lot of Canadian companies recommend this. And I'm like, well, why do they recommend this? And I talked to somebody in Europe. So Bitzer, for example, if you look in their manual, they say N4.5. So that is actually higher than the Coleman grade, because a Coleman grade, industrial grade, or refrigerant grade is called, this is N.4. Do you see there's 1, 2, 3, 4 nines? When you have 99.99% purity, that means N4.0. And like, it took me a long time going through all this European manuals, all these North American manuals, and then going into all these refrigerant, these industrial gas manufacturers manuals to try to put all this together. And maybe somebody out there already has all this, but I know I spent a lot of time trying to figure this out, because the big thing is that, well, what should I be using? When you start to get lower grade than, say, Coleman grade or even bone dry, so Coleman's N4.0, which is the refrigerant or instrument grade, they call it. And then bone dry is 2.8 and 2.8 grade. When you start to get lower, the lower you go, there's more moisture, but it's not the moisture that I would really worry about. It's the oxygen that could be in there. It's the nitrogen that can get in there. And this is why you don't, if you start to go lower than that, you don't know the contaminants that may go into your systems. So I'm fine, even with industrial grade, I bet you get away with that. I've seen and heard about studies that when you're taking the CO2 out, systems running for years have 50 to 75 parts per million of moisture in the system. I'm not saying that's right, but still that's a lot. But these refrigerants, say Coleman grade has less than 10 parts per million. Bone dry, it says less than 20 parts per million, but I've seen other documentation depending on the manufacturer, the industrial gas manufacturer who's putting it in the bottle, say less than 10% for bone dry. So now I have to reach out to these manufacturers because I don't know. I've seen two different documentations from two different gas manufacturers. One says bone dry is less than 20 parts per million. I've seen other ones that are less than 10 parts per million. That makes a bit of a difference, right? So, because you could be one part of the world buying one grade of refrigerant, in another part of the world, it has a different purity level, even though it's the same name. So this is why it's important to understand this stuff. And I believe if you only can get bone dry, put it in. put it through a dryer. I put everything through the liquid line filter dryer anyway. This is why we have the liquid line dryers in the system. I know there's manufacturers that are going to disagree with me. That's fine. But as a technician in the field, I need to get my customer up and running. They got millions of dollars of food in there or a process. It doesn't matter if it's Coleman grade or bone dry. I need to get them up and running. And I've seen other ones where they say, well, you can't use Dewar tanks. And what Dewar tanks are these larger tanks. They have like a refrigerant circle on them and they're a lower pressure. So you get like 300 or 400 psi, less than 30 bar, I would say, 20 to 30 bar inside them. So this pressure is not very high in there. But if you're in a situation and you need refrigerant, there's no reason why not to get that to get your customer up and running. I continue to hear that people don't have access to CO2 in North America. There's there's remote places that your wholesalers don't store it. And a lot of times your wholesaler is not storing it. You're going to a gas manufacturer. But I think we can really reduce this by taking a look at what type of gas they even have. This is a big thing. If you're a technician out there and you're listening, you want to call and find out what kind of gas they have. What grade is it? What's the purity level? They probably, unless you call them the gas manufacturer themselves, if you're talking to a wholesaler, they probably don't know. Some of them may, but I really doubt it. I know you'll be going to the Lindy's, Air Gas, or A Supply, maybe Air Liquid. There's lots of different ones, but you got to understand that stuff because this here is something that really confused me. And then going up in grades, you can go to a research grade. There's a laser grade. There's a lot of different ones. So what I've researched, it goes from grade 2.5, then 2.8, as you can see here, then 3.0, then 4.0, then 5.0. And like I said, Bitzer recommends in between these two and one of their manuals, not all of them, 4.5. And really, that's the moisture content. But you start getting lower than bone dry, you don't know. It's not the moisture that I worry about. It's the other non-condensables potentially inside your system. This is why it's good to look at these manuals, right? This is why it's really good to get a better understanding. A few other things in the manual here is when they talk a little bit about it, a bit more. What I like about here, that they say the high levels of moisture with CO2 can form carbonic acid. And this is like any refrigerants. You can have, it's the POE oil. When you got POE oil, you got moisture, you got heat, it starts to break down that oil, and that's what causes the issue. Once again, you need to go inside your system, and you need to look inside your system, look into sight glass and see if you got moisture in there. And you should be taking samples once in a while, especially if it's a big process. If we're talking about you get tens of thousands of pounds of CO2, because there's lots of systems out there that have that much CO2 in it, you got to take some samples. And even in supermarket stores, when you have 2,000 or 3,000 pounds, a couple thousand pounds, you should at least take a sample when you're doing that oil sample and just have a look. What's the purity level? And you should, I really believe you should be doing those maintenance processes, is changing the liquid line filter dryers anytime you open up the system. Changing when you're doing an oil change, you should be changing everything, the oil filters, the oil separators. You should be cleaning all the screens. Don't be just doing one thing. When you're doing that job, do the whole maintenance, so you don't have to go back and worry about it later. Because I see this time and time again where a maintenance is being done and only really 70% of the maintenance is done. And I totally understand there's situations where the customer is they're not paying for the maintenance. They don't want to pay for the maintenance. And you have your hands are tied. You need to get paid for the work that you do. But if you're paid to do a maintenance, do it correctly. Do it correctly, okay? They show signs here. Let's go down a little further. Let me zoom out a little bit here. Let me go, and I'll show you just one other thing that I like about their manual. They got the kind of the schematics here. You really got to get into their P&ID drawing. So if your customer purchases a rack, that should come with the rack. So every vapco LMP rack is going to have a schematic. So this is just a rough drawing, but when you get in, actually have the rack, you should have all the piping schematic. You should have all the wiring diagrams. You should have all that information there to really help you to be able to troubleshoot the system and maintain the system. But we'll go down. This is the basic side of it. It's showing the high and low pressure. One or two more sections. I like this. This is a new one that they put in their manual. And this gives you an idea of the different pressures in the system. It's showing you where the liquid is. It's showing you where the vapor and gas is. And this is important in the different stages. As you can see, you got high pressure discharge, intermediate pressure, high pressure gas, cooled gas, liquid gas mixture, and suction. So this is important because in CO2 systems, as we know, a lot of you have been here week in, week out, is that there's different pressures in the system. And as a technician, you need to understand this because it's not like you just go to your tractor trailer and grab any pipe out of the tractor trailer and take it in and start piping it up. If you're going from the parallel rack up to the gas cooler and you're using high pressure pipe, it's not K copper. It's not K copper. It might be K65. It could be the Mueller style, XHB, whatever. But you need to make sure you don't mix that up because this is happening out there. Technicians in the field don't know. They got a bunch of pipe. They know it on the schedule. It says 2 and 1, 1 and 1, 7/8, whatever it is. They go and grab that pipe, put it in, and start brazing it up. But the problem is that pressure rated pipe is not correct. This is something that is very key to understand, especially if you're in construction. This is some of the differences that maybe someone didn't teach you. You're going out to do a construction job on a new CO2 store. You never did one before. There's different rating pipe where before you all the same pipe in that tractor trailer that comes in with all your tools and your fittings, it would be all K, we'll say, for a regular HFC store. Now today it may not be. Different sections, you can see, look, different section of this could be different pipe types. This is key to know because you're not going to do a startup that whoever's doing the startup will stop that. Like if the manufacturer's there or if the inspection agent, the local jurisdiction, and I don't know how often that comes in, they're checking the pipe to make sure. And on the legend, this piping schematic, this P&ID, it will have or should have what section of pipes they're using because as the size of the pipe goes up, the pressure rating goes down. You're like, well, what do you mean? Well, the big thing is when I first started looking at CO2 back in 2014, 2015, the gas cooler condensers were made of copper except the header. And that's still a lot of ways it is done because that 3/8, that really tiny pipe has a thicker pipe. It's thicker. The durometer rate, and I don't know if durometer, that's not the right word, but the thickness of the pipe is thicker at 3/8 than when it's 7/8 or 1 inch. So it can handle a lot more pressure because this was a question I had. How come I see all these copper pipes coming out? I was told that copper at that time, I didn't even know there was such thing as high pressure copper with the copper iron alloy in it. But I've seen it on there, but it had a stainless steel header. And this is what you need to know. As the pipes start to get bigger, the pressure rating starts to go down. And when the pressure rating goes down, that means you may not be able to use that specific pipe when you hit a certain section of pressure in your system. And they do have another section in here to talk about that. Could be right here. This is I really like this about their manual, is they put the piping materials in here. And this is why you need to read these manuals over and over and over again. The first 3 times I probably read this manual when it used to be the LMP one, it was in there, but I didn't really recognize this. I didn't really think how important understanding the different types of pipe. And as you can see here, this is the normal K-type copper right here. And as you start to get bigger pipe, look at this. You go from 3/8, it can handle what, 1,074 psi upwards to 72 bar-ish. Yeah, 73. I should have known that's around the critical point. But 72 bar. But when you get down right down to here, inch and 3/8, it only can handle 532 psi, which is like 30 some bar. Can handle the pressure rating of that pressure relief. And the biggest thing is everything behind or upstream of the pressure relief needs to handle that pressure. That makes sense. Okay. So if you're in construction or you know people in construction, send them this. All this information will be under P&ID. And then when you look at the Mueller copper, you can see right down here, if you get back to that 3 and 1 3/8, we can do 800 psi. So this would be like K65, the wheel end stuff in Europe. Mueller maybe in Europe, the XHP. I don't know that yet, but this is important. This is what's in the manuals. A lot of people are looking for, I want all the technical stuff. But when you get down to this engineering side and you understand this is going to help you, because now you know at this temperature too, once again, it all goes in temperature as well. That changes the pressure rating of the pipe. And look, and they break it down. What I like about this was added to them. They break it down K65, XHP, and stainless steel. Because here in Canada, stainless steel. This is the most common, coming from that parallel rack going up to the gas cooler. It's code. It has to handle a certain amount of burst rate. Stainless steel can. One thing though I'm seeing, though, we talked about purity of CO2, the cleanliness of systems. When stainless steel is being used to pipe, the systems can get really dirty, depending on who is doing the welding as well. Because we know a lot of welders, they don't know that the system needs to be super clean. There are some out there, don't get me wrong, but a lot of dirt in these systems. So a lot of the filters are getting plugged up very quickly. So when you're doing a startup, you really need to understand that and diving in that. There's a lot more in this manual that you want to look at, but I want to dive into a few of those things in that manual, because this is the key to understanding the system. And I know reading these manuals are real, it's tough. It's not super easy to take your time to go in through the manuals. Some of them are 40, 50, 60 page. I think that one's 45 page. And at the end of that one, it shows their defrost section, because I get a lot of people asking, well, how does the defrost work? Every manufacturer is going to do it different. Some are going to use electric defrost, and I think that a lot of that's going to be in the US and maybe even in Europe, because a lot of people say they see it in certain parts of Europe, but it's hot gas defrost. Here in Canada, a lot. There is some electrical, not too much though, because you can get some great heat. But is it from the transcritical side defrost? Is it from the low discharge compressors defrost? There's different ways of doing it. You could even take it from the flash tank. I don't know if anyone has that design. I think there may be a design or two, but you really want to understand how you're doing it. I think a lot of people think, oh, well, it's the more heat, medium temp, you got higher heat on there, but it's all about that latent transfer at the end of the day using hot gas defrost. How much latent heat are you pulling out that coil? Because I used to think, oh, it's temperature, okay, because it's hotter, this has to be better at defrost. Well, not necessarily. How fast is that moving? What's the flow? What's the mass flow of that gas going through the coil? Is it going super fast, or is it going slower? So that makes a difference on that latent heat exchange. So things that I didn't think of as a technician, but when you think of it as the engineer side of it, makes a massive difference when you're understanding that. Okay, let's dive in. Once again, you can see the first section just talks about the basics of it, some different components. This is the advancer manual now. I really like this. They continue to evolve it, the Hillphoenix manual, which is great. But service procedure, this is a section that if you're working on any of their manuals, you need to be reading this in many times. This one here, I'm going to dive into the service procedure here, and you just have to go on Google and search it. Go Hillphoenix CO2 manual, the vapco system LMP manual, or Kaiser Warren transcritical manual. It's all there. But the big thing is spending that time investing in reading. It's easy to find the stuff, but it's not easy to spend the time and research and write stuff down and take notes. That's the big thing. That's really how I'm getting ahead in my CO2 information. So right here is they talk about the copper and stuff, but I want to drive down like right here. Look, they even put it in theirs as well. They talk about the different things because this is a big deal. This is a big deal. If you haven't installed a transcritical CO2 system, you got different types of copper. Just remember that. You could have stainless steel, you could have high pressure copper, which is Mueller K65, sorry. You could have K copper, you could even have L copper, all in one system. And then it makes a difference if it's hard or soft as well. So you do have to dive into that stuff. And another big thing is the fittings. Understanding those fittings that you have. Are they the right fittings? You don't want to take K fittings and add them on to a high pressure system. They do look different. They feel different. The high pressure ones are heavier. You have to keep that. Don't be mixing up those fittings for sure. That's very important. But I want to dive down a little bit. This section here is pump down, I think. Pump down to the receiver for standstill purposes. So important. Like I have a lot of technicians who said, like, Trevor, I'm worried about pumping down a CO2 system. I'm like, have you ever pumped down an HFC system? Have you ever gone to a rack? Oh, I have pumped down dozens and dozens of them. It's no different than pumping down a CO2 rack. It's just you got to watch out for a few things. Because an HFC rack, if you close that king valve, you shut it, you stop flow out to your store, stop the flow, and then all of a sudden that receiver starts to fill up with that synthetic refrigerant, starts to fill up with 404, 47F, or 448. It doesn't even matter. Starts to fill up. What are you looking for? You're looking at the pressure. You're looking at the level in that receiver to make sure that if you start to get too much in there, if you don't hear those compressors cycling off, that's the time you need to be concerned. But if when you start to see them shut off, you don't see that receiver level at 100%, then you know that it's going to be pumped down. And it's the same thing. That's why startup and commissioning is so important. They got to go through this. And a lot of people say, well, I used to be in my first few years, I didn't want to pump down a rack because I was worried that it wouldn't start up. It's way better to do it in the day. Well, you can call your manager, you call someone else to come and help you, than when you try to pump something down in the middle of the night. And we need to really start troubleshooting while the system's running normally. This is what I'm teaching more and more people to do is when you're out in the field, look at some equipment that's working properly. Instead of just leaving the site and taking 15 minutes or 20 minutes to look on social media, which is not bad when you're on your own time, but when you're on work time, learn a little bit more. Take your meter and go check a few things. Check that relay that's getting 24 volts versus the one that's getting 120 volts. What's the difference? Check if it's 24 AC or DC, because spending the time in electrical wire drawing is really important. And then reading the procedures. The procedure that Advancer says right here in their manual is different than another manufacturer's procedure, and what to do when you're pumping down a rack. Here you can see that they explain that they have different bar rated pressure reliefs on it. Okay, they do a great explanation. They talk about close the flash tank outlet valve, feeding the store loads, verify the hot gas injection to the medium temp is closed. If the CO2 liquid is at or below the highest cycle class and the low temp, medium temp compressors pump down and cycle off, turn off the compressor's panel switch, close the flash gas bypass valve, close the flash tank inlet valve, rotate the three-way valve, close the reservoir valve to the inlet line. So they're saying it step by step, but this is not the case everywhere. Like I know here in Canada, in Ontario, that by code, they have to be the same. So you got 45 bar on one side and 45 bar on the other side. So that's about 650 PSI, where here you got different ones. And depending on where you're at, this is why you need to go and look at that P&ID, and you need to get a good understanding of it. This is why you got to get into these manuals, and you can read these over and over. Like I'm not going to go through the rest, but look, if the CO2 liquid level rises above the highest site class, now you should be concerned. This is kind of looking at your HFC rack while you're trying to pump it down, and you see your level gauge at 100% and your pressure starting to rise on your microthermal or your E2 because you don't know how much more gas is in there. Someone probably jammed a bunch of gas in there, probably didn't know how to fix the problem, just added the gas thinking they were fixing a problem, but didn't. Too much gas in a HFC rack is no different than having too much gas in a CO2 thing. You're going to pop that or blow that relief because you get too much pressure inside the system. They talk about what you need to do step by step on if this starts to happen with you. Immediately close the flash gas bypass service valve. Immediately close the flash tank inlet service valve. Note the medium temp compressors will go off on high discharge. So they walk you through it. But you got to always update it because you got to look at this manual maybe in 6 months. They might have a different way of doing it. Maybe they've learned from that and they got a better way of doing it. A big thing is that what I really believe more systems need, and I'm going to talk to more end users about this, there should be an auxiliary unit. I think every like supermarket rack or industrial rack needs to have an auxiliary unit on that flash tank. This is something that will make a technician's life so much more easier for service, maintenance. But this is just one little section. And I didn't even go through the whole thing. So I recommend going into the description, looking up their manual, downloading their manual, highlighting, writing on it. This is how you're going to get better. Last, I want to dive into the Kaiser Warren one. So you'll see same thing. They break it out with the introduction to get into safety handling. But what I want to do is go down to where they have their P&ID that they put in here. So this is just a schematic. My good friend Ignacio sent me so this is a P&ID, and this is an example of one of theirs. This is what you need to do. You need to get this of that actual system because it's going to be different. Every system's different. You could be going to any manufacturer, and even though it's the same model, There could be a transducer in a different spot. There could be a service relief valve or access valve in a different spot. This is how you learn about what they're doing. And this is great on this one here. What I really like about this one here, you can follow it. And this is what you need to do is you need to follow. So here's the medium temp compressors. This is where it all starts. Here's where the magic happens. We know that you always have to start up those medium temp compressors. So these start up first. So you start up a percentage of the load. That's going to be in the manual. It's going to tell you what percentage. Kaiser Warren's going to say, we want, start with this. It could be 3 circuits, could be 25%. It could be getting all 100% of the medium temp up running before the low temp at all. And as a startup service technician, you're going to learn the way you can do it the most efficient, effective, and safe way you can do it. Because you don't have to start up 100% if you don't want to, but it's a good way to understand how to do it. And I highly recommend when you do startups, try different ways. Maybe do 50% if the manufacturer says that instead of the whole 100% or vice versa, because you want to follow what I've done because they've done lots of them, but they are also talking to the masses and they're teaching to the masses. You've started up 20, 30, 40 of these racks. You're going to learn ways to do it a bit more efficient and effective because you have a lot of experience doing that. So maybe there's certain ways that you can get that system running up quicker than what it suggests in the manual. But I always recommend you have to start with what the manufacturer suggests. But as you build your knowledge on those systems, you're going to evolve. And even the manufacturers evolve because I've seen manuals change over the years where they'll add something more because they've learned something over time. And this goes for all manufacturers out there. It doesn't matter what part of the world they are, they're evolving as well. They're adding new things, new components, high ambient strategy, new controllers that come out, testing things. And sometimes as the end user or the contractor, you are the guinea pigs for certain components. And then that manufacturer's a guinea pig from the component manufacturers. This is just the way it is because here's my new valve. We don't have this valve anymore or this controller anymore. You're going to have to try this. And then they got to test it out. And then there's hiccups. There's refrigeration. It's just the way it is. There are hiccups. We got to understand that. But we got to do this stuff safe and make sure we're doing it safe. So the way I do this, I always just follow the flow. Sometimes these arrows are not on a P&ID. So you just follow the flow. Here's my header out there. Oh, they got a temperature probe right here. So if I was working on the system and I seen this temperature probe right there, I'd be thinking, where does that go? What is it looking for? We can all assume that this is just past the discharge header. This is the discharge line temperature. But if I looked at this thing, that's taken all 4 compressors into account. This is just a drawing out of their manual. It's an example. Is there one of those on every discharge line? Once again, there's going to be costs involved. Are they paying for all the discharge transducers or not? This all depends. You want to make sure that you check each one. This is one of the biggest things, even at HFC I've seen, I've done it, as well as CO2, is that if you're taking this, look, there's a pressure transducer right here, right? And temperature probe there. One transducer, one temperature probe we got 4 compressors on there. What if there's 6 or 8 compressors on there? One temperature probe, one pressure transducer. You don't know what this middle compressor is doing right here. So sometimes you'll have to check that stuff. And we know on CO₂ transcritical, you cannot use the normal gauges that are used today. You need a set of high pressure gauges. So important. I really believe that every site should just have its own, as long as the technicians don't take the stuff. It's for that rack. For the amount of that rack cost, you should have one set of transcritical gauges there. And everybody should be taught how to use it, how to at least add gas to a system. Because even I know people that are adding gas to HFC systems don't know how to do it properly just because they weren't taught. Can't blame them if no one's teaching them how to do this stuff and they're just trying to figure it out on their own. And that's what's happening out there. So make sure you have the proper tools for CO₂. It's no different than when you go from residential AC installs to, say, commercial HVAC. You're going to be using different tools than from install to service. So it's the same thing here, going from HFC supermarket where you might have some different tools in CO₂, and the gauge is one of the big one. But once again, I've talked to technicians and work with technicians that do work on hundreds of CO₂ stores, and they don't use gauges at all because they use a controller. They can read that information, and that helps them. because they can get into mainframe, or not the mainframe, but into the controller and take a look at all the pressure transducer. And then if one is reading way off, they can compare it to maybe 3 or 4 other ones and give them a good idea if there's one running wrong. That's when they can get the transcritical gauge out and go match it up and kind of get an idea. Is this pressure transducer way off, or is the wiring an issue? What's going on? Is there dirt in it? So they can check that stuff out. From there, I follow the flow. So it goes into this first device, a separator. From the separator, it goes around, and then you get some. What do you guys think that is? What do you think's on your discharge line? We got a lot of heat. Heat goes into space, comfort heating, water heating. So they got this down path, Kaiser Warren. Like, now you can really get the most efficiency out of a CO2 system by using that heat in there. For years, too many years around the world, we're just throwing the heat to the atmosphere. Where I know even here in Canada, we did a lot of heat recovery at the companies I worked at, but most of the time it's turned off. I do tons of supermarket training and talking with guys, and it's like, yeah, heat reclaim's turned off for this reason or that. People don't know how to work on it, or there's a leak in the heat reclaim side, or the end user think it's costing them more energy than their resistive heaters. Okay, so these are the things that really need to understand. But when you're using heat reclaim, heat recovery with CO2 is by far the best refrigerant for that, because you can get so much energy from it. Then we go into the gas cooler, which is right here. Right? And then there's different valves and check valves. And this is what you need to dive in, because when you're looking at a PNID and it says there's a check valve there, is it actually there? You got to go check this stuff. You need to go verify it. This is one of the biggest things. I used to think, okay, I got it from this manufacturer and they build millions of units and they spend millions and millions of dollars on research and development. Mistakes happen, because I've got burnt a few times because of it, where I think, oh, well, it's this system. I've installed the same system 6 times, but that day, whoever was working on the floor of that manufacturer made a mistake. Maybe put the wrong part on, put the wrong pressure transducer, put the wrong component on, which happens. But me as an installer or commissioning or startup guy, I need to do that verification. I can't blame anyone but myself if something happens. A component fails because I didn't check before. Because I've done this with compressors. I put the wrong compressor in and cause a failure right away. And this happens out there. This is something you got to learn from. So I learned that anytime that I'm working on a new piece of equipment, I go through it step by step. And I know a lot of technicians are being rushed out there, pushed out there to get stuff done. But the good technicians they stop and they say, no, I need to make sure that this stuff is correct, because if I don't, then I am on the hook for issues happening down the road. And because if issues happen while you're the one installing and commissioning it, that's on your watch, because you need to go through this. And you got to tell your boss or your manager, listen, I need time. And the end user, I need time to go through this equipment. Because if I don't go through it now and do it right the first time, you're going to be spending years and years of your money on this piece of equipment that's not working properly because I didn't have enough time to set it up right the first time. When are you going to come back and fix it the next time? That's the big question. When are you going to come back and fix it right the second time, or the third time, or the fourth time? Spend the time to understand the system you're working at to make sure it runs properly. There needs to be more, even in the HFC side. There's so many systems running out there inefficiently because there's no recommissioning done. Taking this old piece of equipment and making it run better. Because there's so many end users out there that think, well, it's running, it's keeping everything cold, it's fine. Well, no, it's costing you an extra 50 grand a year because you're not setting up the super heats. You're not adding a drive to the rack. You're not getting a new controller. You got an old Comtrol or RMCC on there. There's upgrades for a reason to make your systems more efficient. Cleaning the coils, the basic one, just the basic ones I see out there that's costing end users so much money. And this is where it can change by you telling them about it. And on these new systems, I'm seeing more and more now that when it starts to get warm out, they're starting to run into issues, and all of a sudden alarms going off because the contractor was pushed real hard, or the timeline was way too short. There's new components removed from the system, trying to design it differently, and you're running into issues. Because I've talked to a few before where they're like, man, my old systems are working great, but now these new systems that I installed, they're not working the same. I get way more calls on these ones than my old ones. Well, what did you do differently? And that's what you got to go look at. And diving into this, you'll figure that stuff out. over time, the different pieces of equipment you're going to start to see, because they're the same components. Like we're looking at a Kaiser Warren manual here. I bet you if you go look at the you go to a vapco LMP unit, you go out to an advancer unit, you're going to have Danfoss high pressure valves. You're going to have Sporlan GC30 valves. You're going to have similar components on all these manufacturers because they're buying from all the same people. So you need to understand how all of them do it. Yes, they do it a little bit differently. They have different control strategies. They have a pipe differently. Their ideas on how the system should work and run maybe a little bit differently. But at the end of the day, it's refrigeration. And we need to spend the time to really understand how that system works. And when you start asking the why and being more curious of what is going on in the system, that's when you're going to take your technician game to the next level. If you're installing, if you're serving, or even if you're designing a piece of equipment. For those that are engineers that are on here and you're designing equipment, you need to understand those pieces of equipment that you're putting on there. I've seen lots and lots of engineers. Okay, I design it's a Bitzer compressor, it's a Copeland compressor, but they don't really understand how the compressors work and what can cause them to fail. They're designing it because they look at the capacity of it for these two conditions, and this is kind of in the rate that they're looking for. Okay, let's pick that compressor, but they don't understand that compressor as well as they should, and they should really understand that compressor. They should understand that compressor better than a technician in the field, and vice versa. This is how you're going to get top quality equipment, is when those engineers understand each component are being designed. How does that work? I've seen it tons and tons of time. The manufacturers have 3 or 4 guys that really understand that specific component on a system, and a lot of the support team doesn't really understand, because it takes years to understand some of this, how it really works. How it really works. I talk about a lot of controllers and I understand how they work, but until you go out in the field and work on them dozens of times and see the way it reacts, because you may see something happen on a system, same component, same controller, but somebody else working on it longer than you understand probably the component better. You've never seen that happen in that specific situation in time. And this is what just comes with experience and time. But the only way to get to that point is doing your research, working on it, putting the work in, investing the time, learning about those different compressors that you're adding to a system, while you're adding that specific one versus a different one. And it's not always about the cost. It's not. I talk with manufacturers. It's not the cost that's what they want to put an awesome system, or the end user. Lots of people say, well, the end users always want cheaper stuff. Yes, they want less expensive stuff. They want to try to get the best price as possible. And sometimes you got to say no. If you're in a manufacturer, you got to say, no, I can't design that at a reasonable price for a fair value. And so this is why you got to come and work together to kind of come up with something that will work. But at the end of the day, it needs to be something that brings value to all parties, the manufacturer, the end user, and the contractor. Because a lot of times what I'm seeing out there, the contractor's left out of the conversation. And this is when a lot of issues come into play, because these are the guys that need to service it, maintenance, maintain it. And then maybe one contractor installs it and the other contractor has to service it. You need to, for any of the end users that are out there, you need to involve all 3 parties, maybe at different times, but I've seen it time and time again where a piece of equipment gets into an area, contractor has to fly people in to start it up, but then who's going to be working on that piece of equipment? From day one, you got to involve the right people to make sure the equipment is running great. This is a great diagram. I'm not going to go through anymore. This is it. So those of you who are listening, get into these diagrams. Start reading about the service procedure. Start reading about the troubleshooting procedure. There's going to be better manuals than others, but you got to read all of them. Like I said, I've read dozens of manufacturers' manuals, from rack manufacturers to component manufacturers, and more I'm learning about it, the more and more I'm curious and wonder why things are happening. And now things are finally starting to click after 7 years, 8 years, 9 years, 10 years. I don't even know how long I've been learning about CO2. It's a lot of years I've been investing in CO2, and I'm still curious because things continue to evolve. Love this conversation. Hopefully you enjoyed it. Once again, share this with others. Really try to share whatever you learn. This is how the industry is going to get better. Share what you know. Share this on Instagram, your LinkedIn platforms, Facebook profiles, because to get better, it's up to you to spend the time investing in yourself. Hope you enjoyed this, and I'll see you at the next Refrigeration Mentor podcast, and see you 2 Mondays.